Right, guys. So question 2 on every single paper 2 has to do with algebra, right? You're going to get questions on factorizing. You're going to get questions on solving equations, even like inequalities, things like that. Okay. So the first thing is on factorizing. I don't know if you all remember how to factorize, but factorizing has to do with writing an expression in a simpler form, right? So for example, if I have, let's say I have um, 3x plus 9, right? If you notice, 3x and 9, they both have a common factor. A factor is a number or a term that can go into another one without leaving a remainder. So 3, the factors of 3 are 1 and 3. The factors of 9 are 1, 3, and 9. So together, 3x and 9 both have the common factor 3. So to factorize, I take the 3 on the outside and I say 3 can go into 3x, x times. And of course, to check it back, you say 3 times x is 3x, right? And then 3 can go into 9 3 times. So this 3 multiplied by x plus 3 is the factored form of 3x plus 9. That's what factorization has to do with, right? It has to do with representing an expression in a simpler way. To me, sometimes it doesn't look simple at all, but that's what it is. You find the common factor and you take it out and you use the distributive law to factor it, right? Now, similarly, if I had, let's say I had 3x squared plus 9x, well, now the common factor would still be 3, but it would have an additional part of it that is x. Because 3x can go into 3x squared and 3x can go into 9x. You ask yourself, what would I multiply 3x by in order to get 3x squared? Well, you'll multiply it by x. And then what would I multiply 3x by to get 9x? Well, I'll multiply it by 3, right? So that, I hope that rings a bell for you. To factorize means that you find a common factor among the terms and then you take it out and use the distributive law to rewrite it. Okay. Uh, Now, when you have this here, 1 take away t squared is something we call a difference of squares. So if you wrote this down, write a little asterisk by it, right? 1 plus 1 minus t squared. This is called a difference of squares. I want you all to make a note of that, right? A difference of squares. And there is a standard way to factorize a difference of squares. The reason we call it a difference of squares is that, well, difference means subtraction, right? So this is a subtraction expression here. And you have two square numbers. A square number is a number that you get when you multiply another number by itself. So the square, just like in general, just to list some square numbers, 1 is a square number, 4 is a square number, 9, 16, 25, 36, 49, etc. Right? 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and so on. So a square number is a number that you get when you multiply another integer by itself, right? So all of these are square numbers, but also you can have terms that are square terms as well. So for example, x squared is a square term, y squared, a squared, b squared. Anything squared will be a square number. And you could even take that a step further. You could say 4x squared is a squared term. The reason 4x squared is a squared term is because 2x times 2x will give me 4x squared. Let's say I had 100y squared. Well, 100y squared, the square root of that will be 10y, right? Because when you square 10y, meaning you multiply 10y by 10y, you'll get a 100y squared. A squared is squared, etc. Now, sorry, a squared, the square root of a squared is a, since a times a is a squared. B squared, the square root of b squared is b, since b times b is b squared. So you have to be able to recognize when you see a difference of squares, which is simply, let's say you have a squared, well, that's a square term, minus b squared. They are two square terms. So we call this a difference of squares. And to factorize a difference of squares, you simply take the square roots of each of them, you put them in brackets, and you interchange the signs. So the factorization of a squared minus b squared will be a plus b times a minus b. And just to show you why it works, well, if I were to expand these two brackets, I'll get back a squared minus b squared. Look, a by a is a squared, a by minus b is minus ab, b times a is also ab, and b times minus b is minus b squared. So what would happen here is that minus ab plus ab will cancel off each other, and you'll just be left with a squared minus b squared. See? And that's the thing about factorizing. When you factorize, whatever you get as your factors, it must multiply back to give you the original expression, right? So this is the general way, this is the general or the standard rule, I would say, to factorize a difference of squares. You just take the square roots of each of them. They will go in your brackets, and you interchange the signs. So like for example, another example, like let's say I had x squared minus 100, then the factorization here will be the square root of x squared is x, and the square root of 100 is 10. So it'll be x plus 10 by x minus 10, right? Anybody wants to try then to factorize this one? 1 minus t squared.
Miss, I do it already.
Thelma.
Bracket two, one, take away F, close bracket, and open bracket, one plus
It's
F, close
it's
bracket.
t. It's t, love. It's t squared. So it's 1 plus
Right?
t. Yeah.
Oh,
By 1
no,
minus t.
the two mixed them up. I thought it
Yeah.
was a F.
Yeah, it's actually T, but correct, right? So guys, that is how you would factorize the 1 minus T squared. I'll tell you, the most difficult thing in factorizing an expression like a difference of squares is really just knowing that you're looking at a difference of squares. Because once you know, then it's really simple. From there, it's just to put the square roots and interchange the signs, right? So this is 1 plus t by 1 minus t. If you didn't get to write it down, don't worry. I will send this after class. The next one, expand and simplify the following expression. 4r minus 5q by 3r plus q plus 3qr. So to figure this out, you first need to expand these brackets using the distributive law, and then simplify by adding all your like terms. All right. So we'll do, if you have, I'm going to show you two ways how to do it, right? So if you have 4r minus 5q by 3r plus q plus 3qr, what you do is you'll take the first term here and multiply it by the first term in the other brackets. So that'll be 4r times 3r. 4 times 3 is 12, and r times r is r squared. Then you take you still take that 4r and you multiply it by q. So 4r times q. Now, because in this question I am already seeing them writing qr, I'm going to write 4rq as 4qr, because rq and qr mean the same thing. Multiplication is commutative. So rq is equal to qr. So 4r times q will give me plus 4QR. I'm just using QR because that's already given in question, right? Now, the second part is I take the second term in the first bracket. Now, this is negative 5Q. So I'll say negative 5Q times 3R, which will be negative, well, 5 times 3 is 15, and Q times R is QR. And then, again, negative 5Q times Q. So that will be a negative by a positive is a negative. 5 5Q times Q will be 5Q squared. All of this has to have to be added to 3QR, right? And now, finally, I'll group all my like terms. So you could write it out as a third step, or you can just work it out from here. You could say 4QR minus 15QR plus 3QR, or you can write it over just to be safe, grouping your terms, your like terms together. So grouping all the terms with QR together. So that would be 12R squared. And I'm going to write them in a different color. Going to put them as uh, plus 4QR minus 15QR plus 3QR. Notice I move with the plus sign, right? And then the final thing there is minus 5Q squared. So this will give me 12R squared, because you don't have any other term in R squared. 4 minus 15 plus 3. So 4 minus 15 will be negative 11. 4 minus 15 is negative 11 plus 3 minus 8. So it will be minus 8QR minus 5Q squared. And that would be your answer for 2 marks. Right. Next, we have solve the inequality. Oh, I did tell you I would show you two ways to do this. The other way is simply how you write it. So from here, from the 4R minus 5Q, all multiplied by 3R plus Q. So if you don't like to do it from right here, you could rewrite it where you take the first term from the first pair of brackets and write the second brackets by it so that you know that you're multiplying the first term from the first pair of brackets by the entire second bracket minus the second term, which is 5Q times the second pair of brackets, right? And then you simplify from there. So that's another way that you could do it. All right, and then you continue. Right, so part C, solve the inequality. Negative 4p plus 3 is greater than or equal to 19 plus 2p. So I'm just gonna do this question down here instead, so I have a little more space. So let me just zoom out a little bit so I can get it. Good. So we have minus 4p plus 3 is equal to, sorry, not equal to, greater than or equal to 19 plus 2p. Okay. So when you are solving an inequality, guys, you solve it exactly as you would a regular equation. The only thing that is different is if you are dividing or multiplying by a negative number, the inequality is reversed. So instead of greater than or equal to, it'll become less than or equal to. That's the only difference when you are solving an inequality versus solving an equation. So I'm going to bring all my p's to one side. So I'll say minus, minus 4p. Now, if I'm moving plus 2p to the other side, it'll be minus 2p is greater than or equal to 19, take away 3. I moved plus 3 to the other side. When you move a term from one side to the other side, you change the sign. So this will be minus 4p minus 6p, which gives me minus sorry, minus 4p minus 2p, which gives me minus 6p. And that is greater than or equal to 19 take away 3, which is 16. And therefore p, so this is the part, right? I'm going to have to divide by negative 6. So this inequality sign will reverse. So it will become less than or equal to instead. So p is less than or equal to 16 over negative 6. So the answer will be p is less than or equal to negative 16 over 6, which is 2 and 2/3. So p is less than or equal to negative 2 and 2/3. All right, so that would be the answer for here. That's 2 marks in the bag. Next, determine the largest integer value of p that satisfies the inequality. Okay, so if p is less than or equal to negative 2 and 2/3, if we think of the number line, right? So here'll be 1, here'll be 2, negative 1, negative 2, because these are all to the left of 0. Negative 2 and 2/3 might be here. So it'll be negative 2 and 2/3. And then you'll have 3, right? So if that's the case, then to represent this on the number line, it'll be a shaded circle and the arrow will be facing to the left because all of these values to the left of negative 2/3 will be less than negative 2 and 2/3. So the largest integer value that would satisfy this inequality will be negative 3. Integer meaning whole number, right? Because all of the other numbers will actually be less than negative 3. So negative 3 is the largest integer value that satisfies this inequality. Okay, so that's 1 mark. Let's look at this question D. The diagram below shows a right triangle with its dimensions given in terms of x. For the right angle triangle, show that x squared plus 4x minus 45 is equal to 0. So we have a right angle triangle with its dimensions. Anybody knows what is the relationship between the sides of a right angle triangle? Anybody just give it a shot? What is the relationship between the sides of the right angle triangle?
What do you mean by the relationship again?
What I mean, so in a right angle triangle, you have a special side, and it's called the hypotenuse. Do you remember which side is the hypotenuse in the right angle triangle?
Uh, um, that's
And
great.
Zinga,
That box, the box.
There's the hypotenuse, I think is the opposite side from the right angle.
Right. So Aaron,
That,
yes, the box that you're talking about, that's the right angle, right? And the
mm,
side that is opposite that, so that would be this side here. This is your
mm.
hypotenuse. Yeah, thank you, Nzingo. So the hypotenuse is the side that is opposite the right angle in a right angle triangle. And another interesting fact is that it's the longest side in a right angle triangle, right? So the hypotenuse in a right angle triangle has a special relationship with the other two sides. Anybody knows what that relationship is between the hypotenuse and the other two sides in the right angle triangle? Let's give it a shot. Fired. Fired, you know?
Miss the X,
Yeah,
the
Shaniqua,
opposite
tell me.
side,
Just now fired. Shaniqua was telling me. Shaniqua, what were you gonna say, honey?
the opposite, oh, and these will be the adjacent.
Well, it would be if I had like another angle. So like Shaniqua, if I had put this angle here, right? Correct. X will be the opposite and 12 will be the adjacent. But we're not even reaching so far as SOHCAHTOA. I'm thinking about a theorem. Anybody know? I feel Jazara might know it. Jazara, are you there? Where's Jazara?
Yes, I'm here.
Jazara, you remember what's the theorem that tells us that gives us the relationship between the hypotenuse and the other two sides? Any clue?
When you get the square of each of the other two sides, it equals to the square of the hypotenuse.
Correct. Y'all, it's called Pythagoras' theorem. Does that ring a bell? Pythagoras' theorem, right? So by Pythagoras' theorem, right? Y'all don't worry if you can't remember it, it's okay, right? I just want you to try. So by Pythagoras' theorem, Pythagoras' theorem connects the basically tells us about the relationship between the other two sides of a right angle triangle and the hypotenuse. And it's basically that, I don't know if you'll ever saw it, it's a squared plus b squared is equal to c squared, where c is the hypotenuse and the other two sides will be a and b. Now, thankfully, that's given to you in your list of formulae. So you don't even have to know it by heart. It would be nice if you do, but you don't have to actually know it by heart, right? But yes, by Pythagoras' theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in a triangle, right, where C is the hypotenuse and A and B are the other two sides, C squared, right, is equal to the sum of the squares of the other two sides. So like, for example, if the hypotenuse was, let's say, 5, and these other two sides were 3 and 4 respectively, right? Then by Pythagoras' theorem, 3 squared plus 4 squared will be equal to 5 squared, right? That's what it means. So similarly, in this case now, with this triangle that they gave us, the first side, well, the two other sides are x and 12. So respectively, x squared plus 12 squared will be equal to 2x plus 3 squared. So the reason this is 3 marks is because the first mark would be allocated to you understanding that or making the connection that it's Pythagoras' theorem that you have to use there. And then the other mark would be in you working this out, and your final mark will be showing that it is equal to x squared plus 4x minus 45. So what we need to do is we need to simplify this whole thing. First, we would have to simplify the 2x plus 3 squared, and then well, we could simplify 12 squared as well, and then work towards obtaining this form, right? Which is the quadratic form. So let's do that. So you have x squared, so that will remain the same. 12 squared is 144. Now, guys, 2x plus 3 all to be squared isn't just, you don't just square what's inside, right? So you wouldn't just say 2x plus 3 all to be squared is 4x squared plus 9. That would be incorrect. To square, to work this out, 2x plus 3 all to be squared, 2x plus 3 all to be squared is actually equal to 2x plus 3 times 2x plus 3. All right, so let's expand those brackets. The left-hand side remains unchanged for the while. Oh, I didn't want to use this color. Sorry. Yeah, so the left-hand side remains unchanged for the while because there's nothing further to simplify there. So you have x squared plus 144 is equal to 2x by 2x, which is 4x squared, 2x times 3, which is 6x, 3 times 2x is also 6x, and then 3 times 3 is 9. All right, now you want to get every single thing from the left, from on all in one side because you want it all to be equal to 0, right? So I'm actually going to move everything to the right-hand side. So here will remain as 0. On this side, I'll have 4x squared. Now I'm moving the x squared from here to the right-hand side. So it will become minus x squared. And then I have 6x plus 6x is 12x plus 9. And I'm moving this 144 to the other side. So that would become, let me use a different color, minus 144. All right. So now this is 4x squared minus x squared is 3x squared plus 12x. 9 take away 144 is negative 135, right? So I could actually now flip it and just write this as 3x squared plus 12x, minus 135 is equal to 0. This is the same thing here, right? The reason I wrote it like this though is because I want to show that it is this and they have 0 on the right hand side. So now if you notice, guys, throughout this expression you have 3, you have 3, 12, and 135. And all three of those can be divided by 3. So whenever you have a quadratic expression or any expression for that matter, and all of the terms are divisible by a certain, or all of them have a common factor, you can divide throughout by that common factor to use to get smaller numbers. So it will be simpler. So 3x squared divided by 3 will just be x squared. 12x divided by 3 is 4x. And 135 divided by 3 is 45. 0 divided by 3 is 0. So we have shown successfully that this right angle triangle, in this right angle triangle, the relationship between the sides can be expressed as x squared plus 4x minus 45. And you write QED. That means proven. So that's your 9 marks. This was the
That
9
area
mark
working day.
question. Yeah, it is. It is, right? So you have to be careful, and I'll show you where you'll get your marks, right? So like I said, guys, even if you didn't know the full thing, you could still reach to a certain point. Like just this part here, this is 1 mark here, right? Because that is that's the principle that you have to be able to recall. And the next part would be your actual working. So like all of this would be your actual working, and that would be your 2 mark. So at least, even if you didn't know how to work it out completely, at least you could get 1 mark for just being able to state this part correctly. And 1 out of 3 is better than 0 out of 3.
Oh, okay.
Great. Good. So I'm gonna put on, sorry, I don't know why the thing keeps doing this where it's like blacking out. Hope you're all still seeing the screen properly. This is May 2025. This is the question from there. Y'all give it a little shot. See if you remember how to do it. Try something, and I'll be right back. Want to tell me what they got?
Miss Anneli done, miss.
Oh, the full thing?
Yep.
Okay. All right. Cool. Anybody did 2 parts A other than Iran so far? Let's see.
So miss, 2 part A is just the same thing. That's all. This one different. It's just x. The answer is you just put x, y
Hmm?
squared, take away x, y squared, x by x squared y equals to xy
Hmm.
bracket y take away x close brackets.
All right, let's see. I think it's correct. Let's see, guys. So to factorize xy squared minus x squared y, we need to see what's the common factor in both of them, right? Now, just for your information, whenever you have indices, right? So like let's say you have x squared, x cubed, the highest common factor among all of those will be the one with the lowest power. So the one that has the lowest power here would just be, right? So if you have to factorize x, let's say this was x plus x squared plus x cubed, the highest common factor, the term that could go into all of them will be x, because x squared wouldn't be able to go into x, right? So it'll be x into 1 plus x plus x squared. That's how you would factorize this. So whenever you have indices, right? The term with the lowest index will be your highest common factor. So like if you had, for instance, let's say you had, um, let's say you had y cubed, y to the power of 5, and y to the power of 9, the highest common factor of these three will be y cubed, right? So that is something to make a note of, something to remember. Whenever you have indices, the highest common factor will be the one that has the lowest power. So in this one, xy squared minus x squared y, you're going to have to look at both of them separately. So you're going to look at x first, and between x and x squared, the highest common factor there will be x, right? And then the y part, you have y squared and you have y. So the highest common factor there will be y. So therefore, the highest common factor of xy squared and x squared y will just be xy. So you say xy can go into xy squared y times, and then xy can go into x squared y times. Guys, to check your answer, simply multiply your factors out. So say xy by y would be xy squared, and then xy by minus x will be minus x squared y. So you see I get the original thing. So that's how you do it, okay? For the next one, 3x squared plus x minus 10. This is a quadratic expression. The reason it's a quadratic expression is that the highest power of x here is 2. So you have 3x squared plus x minus 10. Let me refresh your memory with the steps on how to factorize a quadratic if you don't remember, right? First thing you do
Yes.
is identify, yeah, somebody is talking.
No, I just
Was it
agreeing
you?
with you.
Okay, right. So you have A, which is the coefficient of x squared, that is 3. B, which is the coefficient of x, in this case it is 1. And then C, your constant, is negative 10. So your steps in factorizing a quadratic, first you identify A, B, and C. Next, you find AC, which is found by multiplying A by C. So AC will be 3 times negative 10. That is negative 30. And then you ask yourself, what factors of negative 30, so what factors of AC can add or subtract to give you B, and at the same time multiply to give you AC. So you list your factors in pairs so that it's easier, right? So the factors of negative 30 in pairs will be 1 by 30, 2 by 15, 3 by 10, or 5 times 6, right? So you have to choose a combination of these factors that when you subtract or add them, you get 1, right? Which two factors would it be, guys? Which pair can you get 1 from?
1,
Which combination of these factors? Tristan, I didn't hear from you for the day.
um,
Which of these? Where's Tristan?
Yeah, miss, I hit.
Yeah, tell me. Which of
Miss,
these combination here could give me 1 if you add or subtract it?
I do the question and I had 6 and negative 5.
That's right. 6 and negative 5 is correct because 6 take away 5 is 1, and 6 times negative 5 is negative 30. Excellent. Good. So once you've identified your factors, you rewrite the expression, replacing the x, your bx term, using those two factors. So it will be 3x squared plus 6x minus 5x minus 10. And then you just factorize by grouping here. So factorizing by grouping means that you factorize these two terms and then these two terms. So the common factor between 3x squared and 6x is 3x. 3x into 3x squared is x. 3x into 6x is 2. Bring down this minus sign. Common factor here is 5. 5 into 5x is x. 5 into negative 10 is positive 2. Well, negative 5 into negative 10. You have your repeated factor, so it should be 3x minus 5 by x plus 2. That is your factorization. Guys, I have a full video on how to factorize quadratics. So if you find yourself in difficulty with this question, I suggest looking at that video and trying to follow along and do some practice questions, which I could send you as well. Tristan, is this what you got? 3x minus 5 by x plus 2? Anybody else got
Yeah,
this?
miss.
Good job.
Yeah, miss, I get up.
Perfect. I'm
Yes,
not hearing
miss.
it. Wonderful. Hi, Eliana. How you going there?
I'm good, miss.
All right. Imani, how you going? Following?
Yes, miss. I am.
All right. Beautiful. All right. Hey, hi, Zaydan. Didn't hear Zaydan for the evening.
Evening, miss.
You good? How you going?
I'm alive, miss.
I'm glad to hear that, Zaydan.
Thank
Anybody
you.
knows how to do this question? 4 to the power of n divided by 4 to the power of 3 is equal to a quarter. Anybody knows how to even approach it?
Yeah, miss, me.
Yeah, how you do it?
So I put 4n over 4 3. What
Uh-huh.
did it say? Yeah,
4
you know what I mean?
cubed.
Equals,
Yeah.
yeah,
Mm-hmm.
4 cube equal 4n negative cube. And then I take quarter equal quarter, 1 equals 4 negative 1.
Huh?
4n take away cube equals 4 negative 1, and so n take away 3 equals negative 1, n equals negative 1 plus 3, and n equals 2. So I'm
Okay.
answer 2.
Perfect. You probably confused everybody, but I totally understood what you meant, right?
Okay.
So,
Yeah, miss.
good job. So, guys, with your indices, right, I want you all to recall your laws of indices here. So, when you have the same base, so like let's say you have a to the power of m divided by a to the power of n, this would give you a to the power of m take away n, right? So, once you have the same base, and you simply subtract the indices if it's division, right? So that's the first rule, the first law of the indices that I want you to recall. The second law is that if you have a to the power of negative 1, this is equal to 1 over a, right? So any number raised to the power of negative 1 is 1 over that number, all right? And you're going to use these two rules here to solve this question, right? So on this side, if you have 4 to the power of n divided by 4 to the power of 3, well, based on this rule, when you're dividing indices, it means that, sorry, when you're dividing indices that have the same base, you simply subtract the indices. So I can write this 4 to the power of n divided by 4 to the power of 3 as 4 to the power of n take away 3. because that's the rule. When you have the same base, you subtract the indices. And the second thing is that 1 over 4 can be represented as 4 to the power of negative 1. That's based on this second law of indices here. Any number a raised to the power of negative 1 is 1 over that number. So 4 to the power of negative 1 is the same as 1/4. So those are the two rules that you have to recall in order to solve for n here. All right. Now, as you can see, I have 4 to the power of something on both sides of the equation. So at this point, once you have the same base on both sides of the equation, what you can do, you can equate the indices. So equating the indices means that I would say that n minus 3 is equal to negative 1. So if n minus 3 is equal to negative 1, then n will be equal to negative 1 plus 3, and so n is equal to 2. So therefore, 4 to the power of 2, that's 4 squared, divided by 4 to the power of 3 is 1/4. And we could check it, You could check it back. Let me show you how you could check the answer. You could say, well, if it's 4 to the power of 2, that would be 4 times 4, right? Divided by 4 to the power of 3 will be 4 times 4 times 4. Let's see if this is really 1 over 4. Well, what would happen here is you could cancel 2 4s on top with 2 4s below. And then 1 times 1 is 1, and 1 times 1 is 1 times 4 is 4. So you see how it works out? That's how you would check back your answer. All right. Let's look at this question C. The lengths of 3 sides of a trapezium are shown on the diagram below. The area of the trapezium is 750 square units. Write down an expression in terms of P and Q for the area of the trapezium. So guys, the formula for the area of a trapezium is given to you in your list of formulae, right? Let me see if I could pull up a question paper quickly and show you that where it is. You have to get accustomed to using your list of formulae, by the way. All right. Are you all seeing the list of formulae on the screen?
Yes, sir.
Yeah,
Okay,
miss.
perfect. So here, the area of a trapezium, look at here, right? It's given to you. It's half A plus B times H, where A and B are the lengths of the parallel sides, and H is the perpendicular distance between the parallel sides. So in other words, if you have a trapezium, right? These two sides here are parallel to one another, and this is your perpendicular height. So this will be A and this will be B. So the area would be half of the sum of this, A plus B, your parallel sides, multiplied by your perpendicular height, right? So that's given to you in your list of formulae. So let's go back to the question now, right? So this, this will be A up here. This is A. This is B, and this is H, your perpendicular height. So to show that, to write the expression in terms of P and Q for the area, we would first recall that area of a trapezium is half of the sum of A and B multiplied by the perpendicular height. So all we need to do here is just write these in, substitute these A, B, and H with the values that we have here. So the area, oh, and A as well, because they told us that the area is 750 square units. So it'll be half of A, which is 4P, plus the 3Q, that's B, multiplied by 6P. And all of that is equal to 750. That's your answer, right? So that would be And you could simplify it if you want, or you could leave it just like that. I think because it's 1 mark, this should be acceptable. If you had to simplify it though, you could do 6p times 3q and then 6p times 4p, and then all of that times a half, right? But this should be fine. Okay. Then the next question, the next part of the question, which is 3 marks, says given that q is equal to 2p, determine the value of p. So if q is equal to 2p, we need to replace q with 2p everywhere we have q in this formula here, right? So let's go. So this would be half of 4p. Now 3q means 3 times q. So 3q, if we're replacing it with 2p, would be 3, and in brackets, you'll have 2p multiplied by 6p is equal to 750. And now we're going to solve this equation. So we have enough space here. So let's see. This is a half of 4p plus 3 times 2p is 6p, all multiplied by 6p is equal to 750. Okay, so I'm going to get rid of this half by multiplying throughout by 2. So this would give me 4p. Well, I could work out what is 4p plus 6p as well. Actually, before we do that, let's do it step by step. So I'm going to leave this as 4p plus 6p times 6p is equal to 750 times 2. I'm literally just writing out all these steps. You don't have to write out every single step, even though I do recommend it. All right, let's simplify here. So 4p plus 6p is 10p. 10p times 6p is equal to 750 times 2, which is 1500. 10p times 6p would give you 60p squared. So 60p squared is equal to 1500. I'm coming up here next. So if 60p squared is 1500, then p squared is equal to 1500 divided by 60, which is 25. So p squared is equal to 25. And if p squared is 25, then p would be the square root of 25, which is equal to 5. So P is 5. And that's the reason that it is 3 marks. It took a little bit of work in there, right? You first needed to correctly substitute the value, well, substitute Q for 2P into your formula for your area. And then the other 2 marks would be to successfully solve the equation. Guys, please, I am going to send you this with all of the work in afterwards. So if you're writing it down and I'm moving too quickly, don't worry about it. You could get it after. But also, more importantly, is if there's any questions here that we're going through that you really don't understand, make a note of it, send it to me after. I will try to help you understand. I'll also send you guys, I'll direct you all to the YouTube videos on solving equations and factorizing if you think that you need a little revision there. So a lot of it at this point is, I mean, I'm not seeing you, so I can't even tell if you 1000% understand. I have to go off of what you tell me, right? But also, you have to be aware at this stage in your academic journey, you need to know the things that are giving you trouble, right? So like so far, I'm going to tell you the topics, right? This is solving equations with substitution involved. This is laws of indices. This is factorizing quadratics. This is regular factorization. Here we had inequalities. We recall Pythagoras' theorem as well with solving, well, expanding brackets, factorizing quadratics again. A difference of squares kind of counts as that too, and expanding brackets. So far, those are the different things that we've looked at. If you finding difficulties with any of those, please let me know afterwards, right? So that I could direct you to the content, the videos, not even just mine, but other videos that might explain it for you. So at this stage, and this is not only for your math exam, this is for all of your exams. As you go through past paper questions, you should be able to tell, make a note, open a note on your phone or like take a scrap page or something and write down the topics that are giving you trouble. This is how you study for an exam, not by just like aimlessly doing questions, but applying some sort of strategy so that you know the ones that are giving you more trouble, well, those are the ones that you should pick up with your teacher or do a little more research on. Okay. So let's look at this one. Factorize each of the following expressions. Again, these two are quadratic expressions, right? What is this one? 2 part A. What do we call this one? X squared minus 49. Anybody knows? What's the special term that we use to describe x squared minus 49?
Difference of squares.
Excellent. It's a difference of squares. So Tristan, how would we factorize it?
Find the square root
Hmm?
of the both terms, the x squared and 49.
Yeah.
So it'll be x
Hmm?
plus 7 in brackets and x minus 7.
Excellent. X plus 7 and x minus 7. Guys, it's exactly like this question here that we started with, a difference of squares, right? So like I said, the most difficult thing in terms of factorizing a difference of squares is identifying that it is a difference of squares. Because of course, if you look at x squared minus 49, those two terms have nothing in common, right? So, however, it can be factorized because it's a difference of squares, since x squared is a squared number and 49 is also a square number. And to factorize it, you use the square roots of each and interchange the signs. So the square root of x squared is x, the square root of 49 is 7. Tristan, excellent explanation. Good job. Part B is a quadratic expression, a regular quadratic expression. So the steps, as we went through before, you identify A, B, and C. So in this one, A is 1, because that's the coefficient of x squared. B is 2, and C is negative 35, right? The next step, you find AC. AC is equal to 1 times negative 35, which will give you negative 35. The next step, list the factors of 35 in, in pairs so that you could now look at the pairs to see which of those two factors will add or subtract to give me 2, that's B, and at the same time multiply to give me negative 35. So it's simple because the factors of 35 are 1 and 35 and 5 and 7. 35 doesn't have any other factors. And clearly, of these two pairs, the only one that could give me 2 would be 5 and 7, right? So now in terms of the signs, it would have to be 7 take away 5, since 7 take away 5 is 2. And then 7 times negative 5 is negative 35, right? Now, the good thing about this one is that you don't have, sorry, the A term, the coefficient of x squared in this one is 1. So you don't have to do the whole long step about factorizing by grouping and all of that, because this one is simply going to be x plus 7 by x minus 5. That's all. So you don't have to do the whole long factorizing by grouping like how we did it before. All right, and there you have it. Those are your factors of x squared plus 2x minus 35. A good thing to do, or good practice, is to multiply all these brackets to make sure you get back this original expression. And then finally, hence, simplify the expression x squared minus 49 over x squared plus 2x minus 35. Guys, you see this word hence? Whenever you see hence, it means that this part of the question has to do with the previous parts of the question. So whenever you see the word hence, that's what it means. Sometimes you will see hence or otherwise. When it says or otherwise, it means that you could solve it without using the two previous parts of the question or the previous parts of the question. In this case, it says hence. It means that to solve this question, it's based on what you got for the first two parts here. So what you would do, well, x squared minus 49, you can write that in terms of its factors, which is x plus 7 by x minus 7. And similarly, you can write x squared plus 2x minus 35 in its factored form as well, which is x plus 7 by x minus 5. And now you can cancel the common factors above and below. The common factor here would be x plus 7 and x plus 7. So in its simplest form, this x squared minus 49 all over x squared plus 2x minus 35 will be x minus 7 over x minus 5. That's it. And that's why it's only 1 mark, because you already worked out these two things and you simply had to put it together here. All right, part B says to rearrange the formula shown below to make M the subject. So to make M the subject is like if we were solving for M, right? So it starts with S is equal to K minus M squared. I'm just going to write it over. And actually, I'm going to put this K minus M on this side. Right? So K minus M squared is equal to S. All I did was switch the sides, right? I didn't move terms from one side to the other side. I just switched the entire equation around. So that's why I maintained the signs. So K minus M squared is equal to S. So that means that minus M squared will be equal to S take away K. Right? Because I moved K from the left-hand side to the right-hand side. And K, this is a positive K here. So if you move that to the other side, it will become minus. Now, the sign of M squared is negative. So I have to maintain that negative sign once I have M on the same side of the equation. Right? Now, I don't want negative M. I want M as a subject. So to get M as a subject, I can divide or multiply throughout by this negative 1. So I'm going to say M squared will be equal to S minus K divided by negative 1. So that would give me, well, if I divide S minus K by negative 1, it would actually become K minus S. K minus S. And if M squared is equal to K minus S, then M will be equal to the square root of K minus S. That's one way to do it. You could have done it a different way as well. You could have just kept it as, let me do this too. If I just kept it as is with S is equal to K minus M squared, here's what I could have done. I could have moved the minus M squared to the left-hand side, so it would have become plus M squared. So it'll be S plus M squared is equal to K. Then I could keep M squared here, and it's positive, so I'm looking in the right direction here, and I'm gonna move S to the other side. So M squared is equal to K take away S. And so M is equal to the square root of K take away S. As you can see, it's the same answer, right? This one, I find the second one that I did here is much easier than the first one, but whichever way is better for you. Guys, I also want you to know that these questions so far, they're all like 2-mark question, 1-mark questions, etc. Don't let yourself get hung up on these small 2-mark questions and 1-mark questions. You're not going to die. It's not going to be detrimental to lose a 2 marks. Of course, you don't want to, but if you are, this is question 2 of the paper. So if you start the paper and you find you are taking more than 3 minutes to figure out this 2-mark question, move on to the other question, right? Because of course the more difficult questions, the longer questions are coming later on in the paper. So you don't want to get like hung up on trying to get 2 marks when you have a 9-mark question in the back, right? Okay, let's look at this one. Very similar to the one above. Do you all spot anything? Here, how would I factorize? So it says simplify x squared plus 7x over 4 squared minus 49. I'll tell you, whenever you have a question like this, where you have a binomial, that's a term, that's an expression that has 2 terms in the numerator and denominator, you should check to see if you can factorize the numerator and factorize the denominator. So somebody tell me, can I factorize x squared plus 7x?
Yes.
Yeah, how would I do it? What would be x squared plus 7x?
You would have to put, well, the like term is x. So
Mm-hmm.
x will go outside the brackets. And inside the brackets would be x plus 7.
That's right. So you have x into x plus 7 because x times x is x squared and x times 7 is 7x. Good. Tristan, I want somebody else to tell me how to factorize x squared minus 49 because you
course.
just told me. I
Yeah.
don't want Tristan or Aaron to tell me this one. Anybody else? How do I factorize x squared minus 49?
Miss, what you know, say you don't want me tell you?
No, I don't want you to tell me either.
We boy.
Okay, let's see. Let's see. And Zinga, you want to try? But I think I heard from you already for the day as well, so no. Let me see. Amisha, x squared minus 49. What is that? What is that called?
Wait, say, miss?
X squared minus 49. What is it called?
Um,
Anybody wants to help her? Who knows? The last
somebody
question
help me,
just had that.
please.
Difference in squares.
A difference of squares. That's right, Zayden. How do you factorize a difference of squares?
Yes, yeah, to find the square root at
So
each
good.
value.
So what would it be? What would go in the 2 brackets?
Well, the square root of x squared is x, and the square root of 49 is 7. So it'd be like x minus 7, x plus 7.
Perfect. That's right, guys. This was the exact question here. Right? Look at here. 2 parts, one part A from the question that we just did. X squared minus 49 is a difference of squares because they're both square numbers. So to factorize, you simply take the square roots of each of them and you interchange the signs, right? Thanks. Mish? Yes?
Yeah, miss.
Right. So now what we do, just like the previous one, guys, we would, just like in this one, where you cancel the common factor above and below, you do it here as well. So look, I have x plus 7 and x plus 7. Now that's the extent to which I could cancel, right? I cannot cancel this x and the x minus 7 below. The reason I cannot do that is because you have a minus there, right? The reason I could cancel x plus 7 in its entirety is because that's the full factor, x plus 7 and x plus 7. So the full answer here will be x over x minus 7. You cannot cancel across addition or subtraction. You could only cancel across multiplication, right? So if it was x over 7x, then I could cancel the x's because 7x means 7 times x, right? But if it's x over x minus 7, I cannot cancel across addition or subtraction. Right. Next, find the value of r when x squared plus x to the power of 6 is equal to x to the power of r. So I'm going to refresh your memory with the laws of indices. If you have a number a to the power of m and you multiply by another number, well, the same number a, but this time to the power of n, it would be a to the power of m plus n. So when you are multiplying by the same base, you add the indices. It's similar to, well, contrary to this one, right? When you are dividing by the same base, you subtract the indices. So in this one, when you are multiplying by the same base, you add the indices. So here you have x squared times x to the power of 6 is the same base. So the answer should be x to the power of what? I'm gonna call someone. Let's see. Um, Imani. Imani. You have x to the power of 2 times x to the power of 6. That would give you x to the power of what? It's on this rule. That when you have the same base, you add the indices. Is Imani there? Imani, are you there, honey?
Is it x8?
Yeah, correct. It'll be x to the power of 8. Good job. Because it'll be 2 plus 6, right? So it'll be r is equal to 8. If you have x to the power of 2 times x to the power of 6, it'll be x to the power of 2 plus 6, which is x to the power of 8. Beautiful. Thank you. And then part 2, find s when s to the power of 3 is equal to 8. Fired, what would s be equal to? If s cubed is equal to 8, what is s?
Um,
What number, when you raise it to the power of 3, will give you 8? Do you know?
no,
Well, if s cubed is equal to 8, then s will be the cube root of 8, right? Just like if you had, like if you had s squared is equal to 4, then s would be the square root of 4. So to find
yeah,
what s is, you do the opposite. So same thing, like if you
yeah,
have, so like if you had s to the power of 4 is equal to, I don't know, 64, then s would be the fourth root of 64. So what's the cube root of 8? Oh, this is your calculator paper, by the way, so you can use your calculator to find the cube root of 8.
I don't know how to find the cube with my calculator.
You have, a sharp,
Yeah,
right? You see in the key that has x cubed on it.
yeah,
So you see above it has 3 roots, the 3 root sign.
yeah,
Right, so to get the cube root, you'll have to press second function, x cubed, and on your screen you should see 3, see it? Like this?
yeah,
Right, so now press 8, and then press equal.
yeah, I get 2.
Yes, the answer is 2, right? So s is equal to 2. The cube root of 8 is 2 because 2 times 2 times 2 is equal to 8. Beautiful. Thank you.
Welcome.
Okay, guys, let's look at this one. Guys, I know some of you are new here, but I want you to know that um, we try in this class, and even if we wrong, nobody's like care, we all trying. And furthermore, I get things wrong all the time, and I'm the teacher. So please don't feel any type of way to get something wrong in class. It really doesn't matter. Now is the time to get things wrong, now is the time to make mistakes. Okay, the diagrams below show a triangle and a quadrilateral. All angles are in degrees and are written in terms of A and or B. For the triangle, show that 2A plus 5B is equal to 171. So if these are angles, we need the reference or the connection that we have to make in our brains is, what do we know about the angles in a triangle? What do you guys know about the internal angles in a triangle? Anybody? The angles in a triangle.
Always add up to 180 degrees.
That's right. So the internal angles in a triangle add up to 180 degrees. So that means all of these three angles here will add up to be 180 degrees. So if I had to show that this is equal to 171, that's where I need to start. I need to show that when I add up all of these angles, it'll give me 180 degrees. So that is A plus 2B plus A plus 9 plus 3B is equal to 180, right? Because the internal angles in a triangle add up to 180. And now you just simplify, so you add your like terms, right? So that's A plus A is 2A, 2B plus 3B is 5B. See, as you can see, it's already starting to look like this, right? And then I'm going to move plus 9 to the other side of the equation. So it'll be minus 9. And there we have it. 2A plus 5B is equal to 171. That's what we had to show, and we have shown it. That's why this question is only 1 mark. All right. The next part, for the quadrilateral, show that 7A plus 8B is 342. What do you know of the angles in a quadrilateral? Anybody? So the angles in a triangle adds up to 180. What about the angles in a quadrilateral? What do they add up to be? Anybody knows how many degrees you have in a quadrilateral?
How much degrees in a what?
In a quadrilateral is a four-sided shape as shown here. Who knows how many
More
degrees
than
in a
180.
quadrilateral? Yeah,
More
it
than
is more than
180.
it is more than 180, correct?
Three,
Anybody
it
knows?
can be 360.
It is 360.
Oh, right, yeah. Right. Nice.
So thanks, Aaron. The the
Yeah, that's
angles,
no
the
see.
interior angles in a quadrilateral add up to 360 degrees. So to show that 7A plus 8B is 342, to start, we'll just need to show that all of these angles inside here add up to 360. So it's 6A plus 3A plus 2B. So that's the first two angles there. Plus 18 plus 3B plus 3B minus 2A is equal to 360. So yeah, add up your like terms. I'm gonna add 6A plus 3A minus 2A. So 6 plus 3 is 9, and 9 take away 2 is 7. So that'll be 7A. And then my others, 2B plus 3B is 5B, and 5B plus 3B is 8B. I'm going to move 18 to the other side of the equation. Since on the left-hand side it is plus 18. When I move it to the right-hand side, it will become minus 18. So 7a plus 8b already looks like this is equal to 360 take away 18, which is 342. So I have proven it. All right, so that's 2 marks, 1 mark each. The third part of this question, which I didn't include here, is to solve for A and B, and that's solving simultaneous equations. I'm going to leave that out for today. Let's look at this one. A, simplify 4 over 5x times 15x over 16. So you will have to, just like with regular fractions, right? What I will do, I'm just going to write it over bigger. 4 over 5x times 15x over 16. So I will cancel, right? Just like if you were working with fractions, you will find common factors above and below or diagonally. So I could say 4 into 4 is 1 and 4 into 16 is 4. And then here, I could say 5x into 5x is 1 and 5x into 15x is 3. So this would give me 1 times 3, which is 3, and 1 times 4, which is 4. Right? So that's one way. If you think it would be easier for you to write it out like this, well, 4 times 15x would be 4 times 15 times x all over 5x times 16 is 5 times x times 16. You could write it like that as well. And then you just reduce, right? So you cancel your stuff above and below. 4 into 4 is 1. 4 into 16 is 4. 5 into 5 is 1. 5 into 15 is 3. X into x is 1. X into x is 1. So you're still going to get 1 times 3 times 1, which is 3, and 1 times 1 times 4, which is 4. And that would be your answer, 3/4, which is 1 mark. All right, let's look at this question. The diagram below shows a compound shape, LMPQR, made from 2 rectangles. The lengths in the diagram, which are written in terms of x, are in centimeters. Find an expression in terms of x for the length PQ. So let's just divide the shape. So let's call this A and this is B. Right? Because if you had a compound shape, that's how it would be, right? You would have to divide it into 2 shapes, 2 regular shapes. So I have the entire length, right? So from here straight up to this point is 3x. So if the entire length is 3x, then from right here, PQ, it would be the full 3x minus this piece up here. Because x plus 3 plus whatever this part is makes up 3x. Right? And if that's the case, then to find what that remaining part is, you would have to take away x plus 3 from 3x. So PQ will actually be equal to 3x take away x plus 3. Notice how I wrote it, sir? It has to go in brackets because x plus 3 is the entire expression. So this would give me 3x take away x take away 3. And that would be 3x take away x, which is 2x take away 3. All right, and now to see if it works out, to see if your answer is correct, well, remember, if here is, let me do a different color. Yeah, if here is 2x take away 3, then x plus 3 plus 2x take away 3 will give me the full distance mn. So that would have to be equal to 3x. So if you wanted to check it, you could see x plus 3 plus 2x take away 3. Well, that would be x plus 3. And if I remove these brackets, it'll be plus 2x take away 3. So x plus 2x is 3x, and 3 take away 3 is 0. So you see how it works out? It works out to be the 3x. So that would be the distance PQ. And then the other one is to find the distance RQ. So RQ is from here to here. Now we already know that here is x plus 1. So from here to here is x plus 1, and we have the entire distance from here to here, that's LM, that's 4x take away 5, then RQ will be 4x take away 5, the entire distance up here, minus x plus 1. So let's see what that would give us. 4x take away 5, 4x take away 5, take away x plus 1. All right, so let's remove our brackets. So this would be 4x take away 5, take away x, take away 1. 4x take away x is 3x, and negative 5 take away 1 is negative 6. So RQ is 3x take away 6. And again, to see if it is correct, 3x take away 6 plus x plus 1 will add up to give me 4x take away 5. Let's see if that's true. Well, 3x minus 6 plus x plus 1 would be, well, all of these are add already. So that's 3x take away 6 plus 1 plus x. So 3x plus x is 4x, and minus 6 plus 1 is minus 5. So it does work out. All right, and that's it. That's it for that question. Let's see the final question. X cubed all to be squared. So this one is based on the rule, the law of indices, that says if you have a number a to the power of m, all raised to the power of n, this will be equal to a to the power of m times n. So if you have x cubed all raised to the power of 2, what would be the answer? X to the power of what? Give it a try based on this law here. If you have a number a to the power of m, all raised to the power of n, then the answer is a to the power of m times n. So Shaniqua, what do you think would be the answer? If you have x cubed all raised to the power of 2, what would it be? Shaniqua?
Will it be x to the power of 6?
That's right. It'll be x to the power of 6, right? Because it'll be x to the power of 3 times 2. Yay, good job. Then part 2 is based on the rule where you divide. So remember, if you have a to the power of m divided by a to the power of n, it'll be a to the power of m take away n. There's a little trick here, but I want to see if let's see. Eliana, you want to give this a try? So if you have y to the power of 8 divided by y to the power of negative 5, the answer will be y to the power of what? Well, how you would find it?
Y to the power of 8 minus negative 5.
That's right. Which would be what?
Well, y to the
13.
power.
Yeah, because it'll be 8 to the power, sorry, y to the power of 8 plus 5, which is 13, right?
Yes, miss.
Yep. Y is the power of 13. So this is the part that I think students made a mistake with this year. Well, when they did this paper, it was here. You see how you have minus, minus 5? But remember, a minus and a minus would be plus. Good job, Eliana. All right. And the last few questions here, I want to finish them, guys. Factorize xy minus y squared. Anybody, give it a shot. What's the common factor here between xy and y squared?
Y.
It's y.
Y.
That's right. So we will have y on the outside. What's gonna go in the brackets?
X take
The
away.
X.
Yeah, x take away y. Perfect. So
Yeah.
y times x will be xy and y times negative y will be negative y squared. Perfect. What type of question is this, guys? X squared take away y squared. What do we call
The
it?
difference of two squares.
That's right, a difference of two squares. Fired. How would we factorize it?
Um, will be x plus y and x minus y.
That's right, x plus y and x minus y. And doesn't matter which one you put first, right? You could put x minus y first, it don't matter. Again, you just need to be able to recognize a difference of squares when you see it. Okay, and then, so this is hence simplify the expression. Remember, when you see the word hence, what does that tell us, guys, about this part of the question?
Then you're using the other two parts of the question.
That's right. We're using the other two parts of the question to solve this part. So this is exactly like the question before where they had x squared minus 49 over x plus 7. So here, xy minus y squared, we're going to use the factors of that, which is y by x minus y. And then we're going to use the factors of x squared minus y squared, which is x plus y by x minus y. And then we could simplify because we can cancel off two of those factors, right? So that would be, we'll cancel the x minus y and the x minus y. So we are left with y over x plus y. And remember, you cannot cancel the y's here because you have this plus sign. All right, and then the last question. I remember one year they had a problem with, they had an error in the question. I don't know if this is the year, so we're gonna work it out together and see if it works out. But if we're stuck, then this might be the question that had an error. I don't know how CXE does this thing where they allow papers to reach students that have errors, but maybe they'll fix it. So the diagram below shows two rectangles, M and N, with their dimensions expressed in terms of x. M is a rectangle whose width is x minus 3 and 3x plus 4. And then N is another rectangle with width x minus 3 and x plus 2. Given that the difference between the areas of the two rectangles is 64 cm squared, show that x squared minus 2x minus 35 is equal to 0. All right, guys. So first things first, it says the areas of the two rectangles. And how do you find the area of a rectangle? How do you find the area of a rectangle, guys? The formula. Anybody remembers?
Most
What's
of
the
Length
the
times
formula?
width.
length
Yeah,
is
it's length
length
times
times
width.
breadth. Yeah.
Correct, right? So to find the area of M, you would have to say the length times the breadth. And similarly, to find the area of this one, you would say length times breadth. And it don't matter which one you choose as length and which one you choose as breadth because it's multiplication and multiplication is commutative. So the order does not matter, right? So they're telling us that the area of M minus the area of N is equal to 64 because that's what difference means. Difference means subtraction. So if I had to represent the area of M, that would be length times width. So that would be x minus 3 times 3x plus 4, right? That would be the area of M minus the area of N, which can be represented as x plus 2 times x minus 3. And they're telling us that that difference is equal to 64. So all we do now is we simplify, well, we expand these brackets and see, well, so that it would be all equal to what they gave us here. So let's go. We'll do, I'm going to use the same color. So that would be, to expand these brackets, you'll say x times 3x, which will give you 3x squared, and x times 4, which is 4x. Negative 3 times 3x will be negative 9x. Negative 3 times 4 is negative 12. All right. All of that minus, now look at this. I need to keep these in, I'm going to put these in a square bracket because I need to work this out first and then distribute this minus sign. This is important in the algebra here because if you just put a minus and just work this out, you're going to end up with the wrong sign. So it's important to work this out and keep it in brackets and then distribute the minus sign throughout. So we go x times x is x squared. X times negative 3 is minus 3x. 2 times x is 2x. And 2 times negative 3 is negative 6. And then I'm going to close my square brackets. That's equal to 64. All right, simplifying now. 3x squared has no other term in x squared, so that'll just be 3x squared. 4x take away 9x is negative 5x minus 12 minus, simplifying what's inside here, it'll be x squared minus 3 plus 2 is minus x. And minus 6. All of that is equal to 64. Is that correct? Let's see. Minus 3 plus 2 minus 1. I think it's correct so far. If anybody spots a mistake, tell me, please. But I think it's okay so far. All right. Right, so simplifying again, you have 3x squared minus 5x minus 12. At this point, I'm going to distribute this minus sign throughout the brackets to remove the brackets, right? So this will be minus x squared. A minus by a minus is a plus. So it will be minus by a minus, which is plus. So this will become plus x. And then minus times minus 6 again will be plus 6. All of that is equal to 64. So grouping my like terms on the left-hand side, I have 3x squared minus x squared minus 5x. I'm just writing it over and grouping the like terms. So minus 5x plus x minus 12 plus 6. I'm going to bring the 64 to the left-hand side one time, so it will be minus 64. And on the right-hand side, I'll be left with 0. All right, let's go again. So 3x squared take away x squared is 2x squared. Minus 5x plus x is minus 4x. Minus 12 plus 6 is minus 6. And minus 6 take away 64 is minus 70. So all of that is equal to 0. And remember, like I told you before, if you have a common factor among all the terms, you can divide throughout by that common factor. The common factor between 2, 4, 70, and 0 is 2 because you can divide by, all of those numbers can be divided by 2. So 2x squared divided by 2 is x squared, 4x divided by 2 is 2x, and 70 divided by 2 is negative 35. And of course, 0 divided by 2 is 0. So there we have it. We have shown that the difference of the areas of the two rectangles is shown as x squared minus 2x minus 35. So QED. And that's a full 4-mark question. Guys, that is all I have for you today, right? Today we were supposed to, according to our plan, right? Our success plan, we're supposed to look at algebraic manipulation, factorization, and changing of the subject, which we have done today, right? So what I'm going to do is I'll send you this, well, I'll post this to the Google Classroom, of course, and I will also send you the blank sheet. So like if you want to try them back on your own, you could try it back on your own. If you feel like you had difficulties with any one part of it, like the factorizing or the solving of the simplifying of the expressions, whatever, then let me know. And I could direct you to some content on that and look at the content and tell me if you're able to follow, right? Now, if you don't want to
Yes.
if you don't want to like do the whole thing here, you can look on our Google Classroom. There are all the past papers. All the past papers are there from 2009 till 2026. I need to upload the 2026 paper. But everything is there for your use. So the algebra question is question 2. All right. So you can go ahead and you can try some questions on your own. I want you to do for me. This is what I want you to do for me and I want this information from you. I want to know when is the other day and time that you're going to allocate to doing your individual work with the math. So I expect a message from every single one of you letting me know what day and time or what days and times you're going to do extra math work, right? Also, I'm going to have a meeting with each of you, a one-on-one meeting for us to create a study timetable for you, right? And that would include not just your math, but all your other subjects as well. So again, guys, success in CSEC is all about strategy and time management, all right? Well, not all about that, but that preparation really does contribute to success in the exam. So I want to help you guys figure that out, all right? That will be it for today.